This is Geometry Lesson 4-6, Congruence and Right Triangles. This is the first half of the lesson. We're going to talk about some algebra concepts before we actually really get into this theorem that we're going to be talking about eventually called the hypotenuse leg. But we're going to jump into right triangles on the second half of this. Before we get there, let's look at a few things. So, some of you guys have asked why the side-side angle or angle side-side is not a triangle congruence reason. And here's why. If we look at these two triangles in this diagram, they have angle side-side matchups. So they both have this 45-degree angle here on P and here on A. They have this side of 5 on AC and PR that are both attached to 45 degrees. And then they both have this second side of 4 units that's attached. And you can see that they have, if you mark these out, they both have the angle of 45 degrees, they have the 5, and then they have the 4. And so they have that line up, but these are two very different triangles, as you can see. That top angle up here at B and Q, that's a very different angle measure between the two of them. And this is why angle side-side doesn't work. Just because triangles have that setup of those three parts being the same doesn't actually classify them as the same. And all the other setups that we've discussed, if they have those three things in common, then the triangles are kind of set in place. So there is one special case where this actually does work. Not I just told you it doesn't. There's one case where it does, and that is actually what happens when we have a 90-degree angle, so a right triangle. And working on solving those right triangles, there's this idea we have to review called solving systems of linear equations. You did this back in your linear algebra class, which might have been a year or two ago for some of you. And one method that we use to solve these systems is substitution. And that's the only method that I'm going to teach. If you can remember some of your other methods and use them successfully, go ahead. But to solve a system of equations by substitution, the first thing we need to do is we need to find the easiest variable to isolate. So I'm going to solve this first equation with you guys, this first set. You can see that my top equation says y equals -2, and then my bottom equation says 4x minus 3y equals 18. So I want to look for one of these equations that's isolated for x or for y, and you might notice that the first equation is isolated for y. So then what that means, if y is equal to -2, I can use my property of substitution to replace y with the -2 anywhere I see it. So what I'm going to do is I'm going to take that -2 and I'm going to replace y with it in the second equation. And so now I have 4x minus 3 times -2 equals 18. And now I can just kind of finish solving this for x since there's only one variable. So I'm going to simplify. -3 times -2 is a positive 6. That equals 18. Subtract my 6 off. I get 4x equals 12. Keep going, divide both sides by 4, and I get x equals 3. So now I have my solution, x equals 3. We already know what y equals from the very beginning of this. We said y equals -2. So the one thing that you always want to do when you're done is actually to check your work on these. You can actually plug your values back in and see if it works. So I'm going to do the check down here. So I'm going to take that x equals 3 and that y equals -2 and plug them both into this equation. So I'm going to go 4 times 3 minus 3 times -2. And if I did everything correctly, I should get that 18 out. So 4 times 3 is 12. -3 times -2 is a positive 6. 12 plus 6 equals 18. That worked. My solutions then are x equals 3 and y equals -2. So if we're thinking about levels of difficulty, that one's a level 1. The first equation was already solved for you and there was no x in it. Here we're going to look at maybe a level 2 question next. So it says 2x minus 3y equals -1, not solved for a variable, and the next one says y equals x minus 1. Well, this second equation is solved for a variable y. So what I'm allowed to do is take this x minus 1, this time it's an expression, and go replace y with it in the equation. So now I go 2x minus 3 times the quantity x minus 1, this is where your parentheses are important, equals -1. And now I just start solving this out for x. So I get 2x, I distribute that -3 through, I get -3x plus 3 equals -1. Combine my like terms, I get a -x. Move my 3 over, I get a -4. I can't have a -x, so I'm going to divide both these by a -1 and I get x equals 4. So I have my solution for x, but this time I don't have anything solved for, I don't have a y value yet. So what I do now is I take that 4 value and I'm going to go plug it back into one of my equations and solve it for y. I'm probably going to go plug it back into the second one because it says already y equals x minus 1. So I go y equals 4 for x minus 1, which is 3. So I get x equals 4 and y equals 3 for my solutions. Now you should check your work, so I'm going to check this. I'm going to use the first equation to check it because I already used the second equation to get y. So I'm going to plug both those values in. I get 2 times 4 minus 3 times 3, and if it works, I should theoretically get a negative 1 out. So 2 times 4 is 8, negative 3 times 3 is negative 9. I subtract those, I get a negative 1. That's what I was supposed to get. It worked. I can confirm that that is my answer. Okay. So this last one, this one's probably at your level 3. This one's going to be the trickiest of the 3. So if we look at the equations, it says negative 5x plus y equals negative 2. So not solved for a variable, and negative 3x plus 6y equals negative 12. Also not solved for a variable. So the first thing we have to do is actually get one of these solved for a variable. You want to pick the easiest variable to get by itself. So the first thing you look is for if there's something that doesn't have a coefficient. And I see that the y value doesn't have a coefficient in the first equation right here. So that's the one I'm going to solve for y. So I have to move that negative 5x over, and this becomes y equals 5x minus 2. Awesome. Now I have something solved for a variable. I can take that 5x minus 2, I can plug it in for y in the second equation. So now I get negative 3x plus 6 times 5x minus 2 equals negative 12, and now I just start to solve for x again. So I start to distribute. I start to simplify. And you might notice you're getting something a little bit odd here, because when I bring that 12 over, I actually get 0 on the right side. That's perfectly fine, because when I divide both sides by 27, I'm still getting an x value equal to 0. That works in this case. So now I got my x value. I need my y value though. So I'm going to take my x value and plug it into one of my equations. I'm going to plug it into the first one. It looks the simplest place to put it. So I go negative 5 times 0 plus y equals a negative 2. Well, negative 5 times 0 is just 0, which means y equals a negative 2. Now I have both my variables. I'm going to plug them back in to maybe the second equation this time because I haven't really used that one much to check to see if I did my work right. So now I'm doing my check. I go negative 3 times 0 plus 6 times negative 2, and it should equal a negative 12. So I get 0 plus negative 12. That equals negative 12. That's what I was supposed to get. My solutions work. So we're just going to kind of focus on practicing this skill here in Lesson 4.6 Part A. So solving systems of linear equations using substitution. Alright, I'm going to actually have us jump ahead to look at that hypotenuse leg theorem because you do need it for the note, for the assignment. So this is the hypotenuse leg theorem that you're going to be using. It says if the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. So the important part on this is that A, you have right triangles to begin with. Then you have one pair of sides that are congruent. The legs always can be attached to the right angle. Well, that implies then that this third side over here on that hypotenuse, if the hypotenuse is also congruent, your triangles are the same. So you're going to be using that to help you get some of those setups for these equations in order to solve. And that's all I'm going to go through now. So practice your 4.6.